Welcome, architects. Today, we dive into the core of enterprise AI, building production-grade agentic applications with the Claude Agent SDK. Let us get started. Let's begin by defining what we mean by agentic applications using the Claude Agent SDK. A standard chat application operates on a simple request-response mechanism. You ask a question, you get an answer. But enterprise problems are rarely that simple. The Claude Agent SDK allows you to build systems that operate on an agentic loop. In this loop, Claude acts as a reasoning engine. You give it a task and a toolbox. Claude figures out the steps, calls a tool, observes the results you feed back to it, and decides what to do next. This iterative process of planning, acting, and observing is what makes an application truly autonomous. While the SDK manages this loop automatically for you, as an architect, you must deeply understand the underlying control flow to build reliable systems and prevent endless loops. Look at this state diagram. It beautifully illustrates the core agentic loop. It starts with a user request. Claude then enters the reasoning phase. If it needs to take an action, it triggers a tool call. Your system executes the tool, appends the result to the conversation history, and loops back to Claude's reasoning phase. This cycle continues relentlessly until Claude determines the task is fully complete. Understanding this cycle is the foundation of agentic architecture. Now, let us zoom in on how you actually control this agentic loop. If you take away one thing from this slide, let it be this: the stop reason field is your absolute source of truth. When you make an API call, Claude returns a stop reason. If that reason is tool use, it means Claude wants to execute a tool, and you must continue the loop. If the reason is end turn, Claude has finished its work, and you can exit the loop. The most common pitfall and a heavily tested anti-pattern is trying to parse natural language to stop your loop. Do not write code that looks for the phrase task complete in Claude's response. Natural language is probabilistic and changes. The stop reason is deterministic. Relying on arbitrary iteration caps as your primary stopping mechanism is also a critical anti-pattern. This flowchart highlights the correct control flow versus the dangerous anti-pattern. You receive the API response and immediately inspect the stop reason. The solid paths show the correct deterministic logic, tool use loops back, end turn exits safely. The dashed red path shows the anti-pattern, parsing natural language for words like done. That path is fragile, unpredictable, and will inevitably break your production systems. As your applications grow, a single agent with a massive list of tools will start failing. Tool selection accuracy degrades rapidly when an agent has more than 5 tools. The solution is multi-agent orchestration using a hub-and-spoke architecture. In this design, you have a central coordinator agent acting as the brain. It analyzes the user's complex request, breaks it down, and delegates pieces of it to highly specialized subagents, for example, one for web search and another for data synthesis. To enable this in the SDK, the coordinator must be granted the task tool in its allowed tools configuration. And here is a pro tip for high performance: the coordinator can emit multiple task tool calls in a single response. This means your subagents can run in parallel, dramatically reducing the overall latency of your system. Visualize the hub-and-spoke architecture here. The coordinator agent sits in the center as the hub. The spokes are your specialized subagents: web search, document analysis, and synthesis. The coordinator uses the task tool to spawn the search and analysis agents simultaneously. Once they return their results to the hub, the coordinator can then trigger the synthesis subagent to compile the final report. It is clean, modular, and highly efficient. Let's dive deeper into how the coordinator communicates with subagents. The absolute golden rule here is context isolation. Subagents operate in completely isolated context windows. They do not magically inherit the coordinator's memory or conversation history. If you want a subagent to know something, you must explicitly pass it in the prompt. Why do we do this? Because sharing the full conversation history causes context pollution. It wastes precious tokens and distracts the subagent with irrelevant details. A classic anti-pattern is injecting the entire global state or the coordinator's full history into a subagent. If you see an option suggesting a shared global database for agent memory, avoid it. Always pass only the specific, relevant context that the subagent needs to accomplish its narrow task. This sequence diagram shows the strict firewall between contexts. The coordinator might have 50 turns of complex history. However, when it delegates to the subagent, it explicitly filters that down to just the essential instructions. The subagent spins up in a pristine, isolated window, executes its logic without distraction, and returns a targeted result. The coordinator then safely aggregates that clean result back into the main history. A critical architectural decision you will face is how to enforce business rules. Let's say you have a strict policy: never process a refund over $500. A beginner might just add "do not process refunds over $500" into the system prompt. That is an anti-pattern. Prompts are probabilistic. The model is highly likely to follow it, but it might occasionally ignore it. For critical compliance, financial limits, or security rules, you must use programmatic enforcement via Agent SDK hooks. A pre-tool use hook allows you to intercept a tool call using deterministic Python code. If the refund amount exceeds 500, your code explicitly blocks the tool execution and triggers an escalation. Use prompts for soft guidelines like tone and style. Use hooks for hard, undeniable business constraints. Follow the path of a tool request here. Claude requests to use a tool, but before it reaches the backend, the SDK intercepts it with a pre-tool use hook. The hook checks hard-coded business rules. If a rule is violated, like our refund limit, the hook blocks the action and forces an escalation to a human. Only if the rule is explicitly passed does the system allow the tool to execute. This is deterministic security in action. As your agents run longer, you must master session management. Long conversations inevitably suffer from context degradation, where the model forgets earlier constraints, and stale context, where data retrieved early is no longer accurate. The SDK provides powerful tools for this. You can use fork session to branch off and explore an alternative architectural path without polluting your main session's memory. When decomposing tasks, you have two primary strategies. If the task is highly predictable, like reading a file and then formatting it, use prompt chaining. It is rigid and reliable. However, if the task is unpredictable, like hunting down a bug in a massive legacy codebase, you must use dynamic adaptive decomposition. This allows the agent to decide its next step based on the intermediate findings of its previous actions. This tree visually contrasts our two decomposition strategies. The top branch shows prompt chaining, a rigid pipeline moving from fixed step 1 directly to fixed step 2. It is perfect for predictable pipelines. The bottom branch shows dynamic adaptive decomposition. Here, the agent starts by investigating. Based on what it observes, the logic dynamically branches. If it finds bug A, it applies fix A. If it finds an unknown bug B, it pivots to researching it. Dynamic logic is crucial for complex agentic autonomy. Let's tie this all together with a real-time use case, a customer support resolution agent. This agent handles billing and returns autonomously. To ensure it doesn't forget details during long chats, we implement an immutable case facts block at the top of its prompt, safeguarding order IDs from being lost to progressive summarization. If a backend tool fails, the agent never silently swallows the error. It propagates a structured error distinguishing between an empty result and a timeout. Finally, the escalation logic must be objective. We escalate on policy gaps or explicit human requests. We never escalate just because the customer sounds angry or because the LLM reports low confidence. Sentiment does not dictate complexity. Mastering these trade-offs is exactly what the Claude Certified Architect exam tests. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final flowchart solidifies our escalation logic for the support scenario. When evaluating an issue, policy gaps and programmatic hook triggers correctly route the flow to human escalation. However, look at the bottom paths. An angry tone or low self-reported confidence routes right back to autonomous resolution. The model must handle the frustration if the task itself is within policy. Learn these boundaries, and you will build incredible systems.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks, you can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.